Okay, good afternoon and welcome back to the Academy of Booseries, all the powder products. Last time we had been doing something on the statistical distributions, and then we started with the beta distribution of the second kind, and then we converted that into the beta distribution of first kind. What we're going to do today that we pretty much going to get back to that we had been doing earlier, that to evaluate the heavy integrals. This time we are using U substitution or differential or change of variable method or revised substitution method formula. Using this any two of these methods, we can easily get done any of the heavy integrals. Let's look at this given integral. I equals tan inverse x over tan inverse x o arctangent over 1 plus x squared. See? Look at this integral. Let's see how we can get this done. So what I'm going to do, I'm going to use the first method, method 1, using method 1. This method 1 deals with the using the revised substitution method formula. Substitution method formula. What that means, we are talking about here revise. In order to talk about the revisions, we have to definitely talk about the original substitution method formula. That means seems like they have like a general substitution method formula has been reduced or revised in such a way that fitting into the particular scenario. Okay, let's look at that. What do you mean by the revise with the substitution method formula? First look at the substitution method formula. Substitution method formula, which is abbreviated as SMF. That's nothing but the integral of the composite function. Integral of the composite function. Okay? Let's say this is the most general formula. So say that you have f of ux and this guy's derivative right next to that one, u prime x dx, then they say that can be given by f of ux plus c, where capital F of x is nothing but the integral of the underlying function. See, underlying function. That's the integral of the underlying function. This is the most general substitution method formula. This is the most general substitution method formula. This substitution method formula, once revised, we're going to refer that one to as a revised substitution method formula. Before we're going to move on to the revised substitution method formula, let's look at some properties on this one. Okay, so here, if you get back to f of ux, here f of ux we're going to call the composite function. The composite function. If you want, you can abbreviate it as CF, composite function. Ux, since it's inside the function, we're going to call that one argument function. I'm going to put the commas to indicate the same thing. Argument function being abbreviated as AF. And f of x not f of ux. F of x is called the underlying function, which is denoted by uf. See? Now we have three types of functions over here: composite function, argument function, and underlying function. We are actually looking for the integral of the composite function along with its argument function's derivative right next to that one. It has been given by the replacement of x of the integral of the underlying function. Okay. So what we are gonna do in our particular this when it been revised, what is meant by the revision? When they say the revised substitution method formula means like definitely some kind of a revision has been done upon the most general the substitution method formula which was given earlier. So now let's go to a very particular case. In particular case, what I'm going to do, I'm going to say let your f of ux is nothing but ux to the n. See, ux to the power of n. See? I need this function in this form, and this is my composite function. And ux stays the same. Ux is ux. That's the argument function. Underlying function is f of x is nothing but x to the n. This is the underlying function. See? In our most general case, all these three components, such as that component, say that CF, AF, and UF, been replaced by their the components of their corresponding that corresponding components of the this argument function, composite function, and underlying function. See, these are replaced. This is my composite function being replaced by uxn. Ux stays as ux. F of x is x to the n. So if you're going to put this back into the most general revised substitution method formula, in substitution method formula we have integral I f of ux u prime x dx equals f of ux plus c, where f of x is nothing but integral f of x dx. So let's plug in this all these components ux to the n, ux to the n, ux and xn for CF, AF and UF respectively in the substitution method formula. So therefore, I equals integral ux to the n, u prime x stays the same, dx, and here this means that, and being integrated, see, integrated f of x, see, if you want I can write the f of x, see, it's nothing but f of x and x has been replaced by ux plus c, see, it's the same. So what I'm going to do, that f of x I can easily replace, you see, I u to the x n u prime x dx equals, this means that integral f of x dx, and x has been replaced by ux plus c. See? So according to our revision, according to our in our particular case, my f of x is nothing but x to the n. See, x to the n, and do the integral and then replace that x with ux plus c. I'm going to write this part too, but since I really want to simplify the right hand side, I'm going to write only the right hand side. So then it's nothing but n plus 1 over n plus 1, and x has to be replaced by ux plus c. Therefore, revised, that means our substitution method formula, revised substitution method formula is nothing but I integral ux to the n u prime x dx equals to, see, x now being replaced by ux to the power of n plus 1 divided by n plus 1 plus c. So you see, this is the revised substitution method formula for this particular case. You see, this particular case. Pretty much what we're going to do, we're going to utilize this guy in order to get our integral done or evaluated. So it's easy. We're going to compare and contrast it and see whether this going to fit into whatever we have been given will be fitted into this given formula. Let's look at our given example, given integral. The given integral is I integral tan inverse x over 1 plus x squared dx. What I'm going to do, I'm going to little bit separate these terms for you to see very clearly. Tan inverse x times 1 over 1 plus x squared dx. See? To make this one more clearer, I'm going to put, you see, 1 over here, power 1. Now it seems like this is like my u, this is my like u. The 1 is like my n, and then I go and see what's the derivative of tan inverse x. Would that be 1 over 1 plus x squared or something else? Yes, everybody who has taken Calc 1, Calc 2, they know that the derivative of tan inverse x should be definitely 1 over 1 plus x squared. So see, the inside derivative is right next to that one. If that's the case, whatever ux should be raised to the power of 1